Anyone who's watching this, I've been asked a few times to see if I could document a little bit about the debug steps I do to find out why stuff fails and how to make it stop failing. So I'm attempting for the very first time to use some screen capture software, so I don't know how this will go. But yeah, first time for everything. The bug that I'm looking at here, I have not actually started looking into it all yet. So I'll try to clip out some parts of the video that take too long, especially on this machine. The brief overview that I know of the bug is simply this little page here. The bug says that there's a seg fault somewhere at the end of system image generation, and the person who did this was nice enough to point out that there is a particular commit here that caused the issue, and well, reverting this apparently fixes it. We can safely say that's not the intended fix, since this is completely unrelated, or at least so we hope. So the first step I had was to get an ARM machine. This is provided by the Scaleway company, and I apparently don't have the username and password information on this browser, but that's okay. I shouldn't really need it. What's important is that I have created a SSH connection directly to that machine, and this is only configured to have root access, so that's what I've logged into. And on this machine, I've already got a Git repository, so I can check the status of it. It's some old repository, so it's noticeably behind right now, but that's okay. That's the next step here. I recently ran a git fetch just to make sure that it was entirely up to date in the git metadata, and that's how it knows how far behind it is. But I can also see I had some changes before, so I just want to check what those were. And glancing through, I quickly see that this was some changes I had in progress the last time I was here. Not very many, and shouldn't really cause issues for us here, but with so many changes in between, we just want to check the stash, and we'll go ahead and put that in the stash. Now you can see our working directory is clean, and I can go ahead and pull in all of the upstream changes, which should pull in this bug and probably lots of other stuff. And then I will go ahead and make clean, because to recreate this bug, it's nice to start with a relatively fresh environment. And then because I recognize the commits, I'm going to go ahead and reapply the stash that I had saved earlier, so that those changes are now right back in my diff here. And I just happen to know those are needed for this machine, and should eventually make it upstream into Julia master when I've had some time to test those more. Alright, on to the bug. The bug says that I should go ahead and make Julia, and that it's going to fail at some point. This machine, I believe, has 2 cores, which I can check by reading the CPU info, and oh no, in fact it has 4 cores, so I should be able to go ahead and do a pretty quick make here. Just tell it to use as many cores, and my preference recently has been to do a make all. That runs debug and release build simultaneously. It's also possible just to run make release or make debug, but I find sometimes it's helpful just to have both available So there's no question of which one might have been newer. I know that both of them are built at the same time. So I'm going to probably try to pause the video here for a minute while this builds. I decided to run a bit of that in high speed rather than just completely eliminating the whole thing. You probably saw me jump around to a few different windows and otherwise get bored and I wouldn't need a piece of pie. Eventually, it finished. There was a few compiler warnings that came past here. I haven't really looked into any of them, but kind of know they're okay, and, well, compiler warnings aren't really what I'm trying to track down right now. So, the interesting part here that we got to the end is that we got an assertion failure. So, I'm not sure why this one was directly segfaulting. My understanding is most people are currently using the LLVM binaries provided by LLVM. Those often have assertions turned off. So anything that would have been an assertion failure and give a nice little message just simply directly segfaults. I'm using a custom make.user file currently, and I can go ahead and show that. And so as you can see, well, actually, I started making some modifications to it a second ago, but the important things that you'll see here is that I've set my LLVM version, but more importantly, I've always turned on LLVM assertions. I find that when I'm trying to track down a bug, that's almost always a good place to start. But now that I've shown that this is an assertion failure, these often actually end up being pretty quick to track down. I want to go ahead and go into base, and then I'm going to type this is just from memory. Alright, so forgive me if I didn't comment there, but it's a little bit to remember at the same time. And attempt to not miss. What did I type wrong? Oh. Right, -ji is no longer an option, it's -so. What I've now given it here, it looks like that one's actually starting, is I've asked it to run from the base folder of Julia. I'm asking GDB to run with the arguments, running the debug version of the output program. That'll run quite a bit slower, but at the end will give us a little bit more useful information. I've told it that I'm doing a build. In this case, I just kind of picked a random character to do this build into the local folder. I've given it the old sys image to load off of. I wanted to make sure there was inference available, so I gave it the inference image. And then I've given it the file to run. Sysimage is our standard system precompilation library, and we'll provide all of base. And that's what we saw going up here. When this failed, that's what this was running. And so I'll let that go for a little while. I'll jump back over to the other screen here for a second. I have two tabs running here. The second one is just a second SSH connection into the same machine, allowing me to run additional commands, check the progress of my builds, etc. I can do things like show that it's running with top. I could look at machine stats. I don't actually know what I have installed on here. Maybe IO top. Yeah, I can see what the disk usage is doing, which is apparently pretty quiet. This is a pretty CPU driven task.
when we look at all of the stats, we can see that pretty quickly. But what I can do is make -n, which tells make to not execute any of the commands, but to just simulate them, and then ask make what command it would have run. And in this case, I shouldn't have changed my LLVM version midstream. Version. You really shouldn't use override, but sometimes it's nice. And sometimes you should use it. It's whatever, 50-50. Make LLVM ver. Alright, so that one got a little bit further. So the first couple attempts you can see here, I was trying to build 362 because I want to switch to that at some point. I don't believe LLVM has actually released 362 yet, so I'm kind of waiting. It takes a while to build each one. I have 360 currently active. Again, I can check that if I need to. Often that's necessary because, well, I've got a number of machines and I need to find out how they're configured. But ignoring all of that, make -n. That was the part I'm trying to show here. And you can see here the final steps of make -n. I already made it, so I need to remove that. Run make -n again. And alright, that's now the command I was looking for. This command you can see is actually describing what exactly was being run by Julia at the time. I think if I set verbose, it'll print a little bit less boilerplate, but not really significantly less, so it's not that much different. But you can see the same commands here, cd base, and then running Julia. This one, I had told it to give it a processor name. It wasn't really necessary. As I later found out, I just haven't removed it. In this case, it was outputting an O file, and the other one I've outputted a .ji. It's not much different in actual behavior. -f, I forgot that flag, but that flag tells it to ignore the user customizations. But this machine shouldn't have a julia-issue11878 file, so that also doesn't matter. And those are just generally things that don't matter when debugging, but are only useful when making sure the build is reproducible. And then the same two final arguments. And so now I just kind of have to let that go for a while. I point this out because it's running the same command. If you want to see other commands, you can touch the old version of the files. So for example, it's often useful just to touch the original version, which would have also had the same effect of making sure this showed up in the output. Just check quickly to see how far this is getting. This is not a particularly fast machine. And it's ARM, so I think as I was showing earlier, proc CPU info tells me this is about a 1 gigahertz processor. So although it's quad core, Julia is not set up to really use that much, so top indicates we are fully utilizing exactly one of the processors. And it'll just kind of stay that way now for a while until we finally get through the system image build. And then I can resume debug tutorial number 1.
I've been letting this run for a while and found out a few things. The first is that it succeeded. So, back up in my log here. While it failed during the system image build, as we showed previously, when I ran the command in GDB, it got all the way through and then exited normally. That sometimes happens, so I just stuck back on those last few arguments that I said really shouldn't do anything, but just to make sure, ran it again, and what do you know, it still exited normally. So I kept looking into this, and at the same time, someone else has been looking into this function issue also, and done the helpful thing, and reproduced it in GDB and did some back traces for me. So this is actually essentially what we're going for here. And what I saw looking at these quickly here is just the backtrace. This wasn't actually terribly helpful, but we can see we did get the assert, and it actually provides some information about where we were, although it was not immediately obvious to me why that's useful. Then I went and looked at the function here, and this immediately catches my eye. There's almost nowhere in CodeGen that we should be emitting a giant array like that. And as we scroll down, we can see a little bit more about this array. It's called merged globals. So obviously this is some LLVM optimization pass that's creating this thing. And in this case, we're using the 954th element of it. So I can't quickly see how many JL value T's are appearing across my screen here, but obviously there's a lot of them, more than 1,000. So I think I think I know where this is coming from, and I think I know how to solve this, mostly just from seeing that this array looks very unlikely, not something I've ever seen before in the AST, and as I scroll down here I can see it's made a number of copies of it. And so from that, I just can see also what I did wrong here. So because this is an LLVM optimization thing, what I had done last time was -- output JI, and I usually do that because it saves a little bit of time, because it doesn't run the LLVM optimizations near the end. But to reproduce the problem, it appears that I need to actually output something that has the LLVM optimizations on it, and so in that case is that it would be -- output -o x.o, or some random file name. And so it's running characters as I try to scroll here, but that's what I have running now. But the net result I expect will be simply that this reproduces the same difference. Now I can show where that is in the source, if I guess right. That's Bo. I haven't gone looking for this yet, so this will be attempting to look it up on the fly here, which may or may not be a good idea, but I can look for all global variables, creations. So I create new global variables for strings. Those are private linkage. I create new ones with external linkage in there, but that's not related. I create new ones for the sysimage gvars and the global unique. All of
these have external linkage. It won't be something with external linkage, I believe, because LLVM shouldn't be able to merge those. External linkage meaning that it has a name visible to the external world. I believe it's one of these Julia-issue11878 global variable items, although, so I know it has internal linkage, but I'm slightly surprised that it merged them anyways, just because we did try to give it a name, gv_name.stir. That's an attempt to put it in the debug info. So it's surprising that it merged it, but that could also be why we don't see it on on the Intel x86 platforms, and we're only seeing it here on ARM. For some reason it's doing a different optimization. Could be any reason really. I can't really say why. But my belief on where this is failing comes from that's external. These are all going to be external. Is when we go to emit bit code, dump the bit code. There's a couple of global variables that we create, and I actually had just run past them in the other function, but didn't point them out. Went through them a little quickly. But I do this gen LLVM GVArray, and if I go back to that function, I've created a bunch of new arrays, and I suspect this one, because of its size, is the JL sysimage gvars array here that we create with exactly what was needed, and then we push it onto this new global variables vector, and then we go back to CodeGen and we delete all of those. We try to erase them from the parent. This should have been valid pre-compilation because the only usage of that array is an external consumer, but it looks like LLVM has decided to merge those into one giant array and eliminate the original array, and so that leaves us with this AST as you see it here. So I think the solution here is going to be to copy the array before we are emitting all of this extra stuff into it, before we emit the .o file. That's pretty straightforward to do the copy. So I'll do that offline and then show the diff. The one other thing that I can look at is I've previously created a sys.ll file. This one may be too old, but this is just a entire version of the same file. What I pull this up for here is it has this variable in here, sysimage gvars, and then we can see what it expanded to. So this has 25,000 elements. I'm actually surprised this doesn't have that many. Maybe it split them at some point, since this is merged global number 95. Apparently there's a number of them. But all the other globals are really small, so I'm not sure why it merged the rest of them, unless they're all strings. Looking back here, I see that all of the string variable constants are being created as private unnamed address constants. So there's a possibility there that all of those are the culprit as well, although this is a JL value T and the strings are not, so that kind of answers that question in the negative. And then I should be able to look for that. And so we know that function was in the big list. It should be also appear much farther down in the file. It's currently searching. There it goes. Okay, so this was the line that it looked like prior to the expansion into merge globals number 950954. We had a symbol here that was, yeah, as I expected, a GV lookup, global variable add exit hook. This is the name mangling that we give it in order to actually be able to do some of this analysis. Try to give it a name that is recognizable. And there's another one, core.function. I think it's even merging this JL method, which is main.base.standard error. So that is clearly what it's done, and also indicates what needs to be done to bring this back into a valid system. So I'll keep running this forward, and I may check one or two of the same things, but the presence of this odd-looking array was what really caught my eye, and just quickly indicates what needs to be done to fix it. Since that now compiles, the next step will be to test and see whether this actually fixes the problem. That's going to take a little while, so I'm going to do so in the background. The diff here, as you'll probably be able to see on GitHub soon enough, it was pretty simple. I just went through and deleted all of the instances where global vars was used, and that kind of helped make sure that I got rid of any place where it might have been used, so that would have turned into a compile error. And then used this LOVM function, clone module, so that any reference that used to be to the shadow module now is to a copy of the shadow module. And that will keep our shadow module valid and unmodified, importantly, during the LOVM output passes. So I'm just looking through here to make sure everything looks like it should. And I can see actually I missed something. Looking back here, that shouldn't have been shadow module anymore. And now if I look back at the diff, the change I just made will be in there. And I shouldn't have to worry anything is broken. And yet it still is, because I messed up the non-MCJIT case still. So I still need to go back and handle that case, which is always good to avoid breaking things. People appreciate that most of the time. Alright, hopefully that's actually correct now. Although the only fix I just did was for the non-MCJIT case, so that won't be visible here. So that old LLVM version change that I did is actually downloading and running LLVM version 3.6.2 now. It's what I want to do, but perhaps not right now. So, or 3.6.1. I'm going to go ahead and continue using the LLVM version that I know is installed. And just override that on the command line until I have an opportunity to compile the whole thing, where I'm not trying to be productive at the same time. although sometimes I'll run those in the background. That's actually why I changed the version number, is I was intending to run it in the background so that when I needed it, it was done and didn't have to think about it anymore. But the new goal will just be to allow this to run for a long time, and hopefully by the end of it we won't get an assertion failure. We'll know that it's fixed, and I'll go ahead and commit and push, and that'll be it. I'll try to walk through some of the debug steps that I would have done to generate this same information on this window when it gets there, and pick up from there. But with this extra information, I was able to do kind of a multi-track here and wait for the debug info to come up while I still create what I believe should be the fix, and test the fix in parallel, which is always nice. Always usually running multiple things in parallel, since a build can take a while. It can be helpful to. The build finished now, so I can reconnect to the existing process and start looking around at the debug information. Now, from the previous build, I did go ahead and rebuild. Let's see, I did a bunch of work afterwards just to check on different things, and kind of lost a bit of history here, but that's okay. I completed a make and got past the point where the previous issue occurred, which means that the diff here does successfully fix it, although it brings up a new error that will need a completely unrelated and different fix, but not very interesting for the video, so I'm not going to go into that. However, now that I have gotten the video to the spot that I was interested in, I will go through some of how we could have achieved similar results here. So when GDB hit the abort call, it stopped and let me explore, and so I could ask, for example, for the backtrace and see quickly here all of the same information, same backtrace that was being provided by the issue tracker, and then I can go ahead and look through that. As we see here, there wasn't a whole lot going on. I was in the add-exit hook, as we kind of knew already, and then I can actually see, though, from this error here that occurred here, I can see where it came from. So I can see here it came from frame 12 when I was cloning the function body. So I can walk up to that, or I can just jump straight to frame 12. This is GDB, by the way, so the shortcuts I use are mostly applicable to GDB. Some of them work in LLDB and will be completely different if you're trying to use any other debugger like the Windows debugger, WinDBG. But jumping up to here, I can list some of the surrounding lines, or list minus to walk backwards. I can hit enter to simply repeat the last command. I can look at the frame itself. I can see that was on line 202, so I can see line 202 is here. And so that's not the final error. Final error was in fact further down. Back up. It was here. Where is the... That seems to be the entirety of the information. Okay, I walked back into the function mover. So LLVM calls back into the C++ code and was calling here. And this is where I wanted to show some of the information So you can see I abbreviated list. I can use some prefix of it and get the same result. But we have let's see, information on the locals. This lists all the locals for the function or frame. And so this function now I could list to walk through it, or I could actually go and open this. But I can see line 282 was the one that failed from typing frame. That's 282. And so I'm trying to set the initializer for the new global variable as an integer value of the right size created, or of the right type created from an AP int. And if I go ahead and look at the GV, some versions of GDB can directly execute this. Other versions get a little bit confused. So there's an LLVM wrapper that Julia provides to look at these variables. And this one we can see is a massive array, which is kind of what we expected from the previous look. And it's merge globals number 95. And there's not a whole lot of additional information, but what's quickly apparent here is that merge globals type is an array, and the element type of that is going to be, well, it's going to be an array. And it's not going to work very well when you try to get an integer and then use that to set the initializer. And besides, this is supposed to be 0 initializer anyways. We can look at both the new GV and the old GV and see that they are the same, minus the 0 initializer is not on the new GV. And that's missing, but not really appropriate. And as I pointed out before, this array isn't really expected to be there. We were getting away for a long time with not copying the module before emitting the code from it. LLVM doesn't guarantee this operation is valid, and so it finally broke. So we've just had to go and actually correct our code to accommodate that. Some of the other things that I could try to look at, I'm not sure which ones are mapped here. So let me walk up and see. This one's pretty good. I can print function. There's a JL underscore, which is a shorthand for just JL static show. Dumps whatever you're looking at to standard error, just to try to get some standard information about it. So F or F lambda info, linfo, are often very helpful. In this case, that's also been extracted into the local LI environment. You can try to look at the AST, but it'll usually come up compressed. So there's a command, uncom, yeah, there we go, tab completion for the, or not, tab completion seems to have gotten confused. There we go. So tab complete, and that takes a lambda info and an AST, and we get back an actual AST. The error wasn't in this AST, so there's not a whole lot of interesting code in here. But the one of the very useful things when you can get out of this is the line numbers. This is very much the same you would have seen if you were to print this AST at the REPL prompt, although not formatted quite as nicely. This is a very basic printer just so that it always works, but rarely gives you the optimal printout. That's kind of the design of that particular function. So again, I can ask for the locals, And in this case, there's quite a few more. Often another thing you can look at are some of, well, we can just say everything in the LI, and everything in the Lambda info. Quickly shows us all of the fields that we might have been interested in. So we could manually explore the name if necessary. We can look at the spec types. A lot of this stuff will be automatically printed just by JL_LI. So spec types is the empty tuple. The name is here, and the name is actually a special object in some cases. Nope, not in this case. Sorry, module is separate. There's some metadata. You can see there's a spec function object and a function object. Those we can go back up or use reverse R search to go ahead and actually look at those. Object spelled out. And now here we see the same thing, that our function object is trying to access this odd global thing, merged globals, 027. And then if we look at the spec function object as well, we see much the same thing. This is the merged globals that wasn't really expected to be there, but got inserted by CodeGen as it tried to improve the AST it was about to emit. And so that's often very useful to be able to do. Other useful things, there's lots of useful variables that are helpful to know about. Actually, one of the ways you can find a lot of them is just to hit tab and see what auto-completes. So for example, we could look at the major and minor fields. Now you'll notice, because I just printed them, I printed the location of the variable, and that's generally not exactly what you were looking for. So you almost always want to put a star there so that you... that didn't do what I expected. So that you dereference it. The type of that is very strange. I'm not quite sure what it's saying here. It's an int void. I would have expected this was an int pointer, but that also doesn't give me the right answer. So this is often a good time to go look at the source code, find out what the thing is. That's not actually where it is. It's in source-jl API. Ah, that's why it's showing up weird. It's a function. It's telling me that this thing, var major, is a function that returns an int and has no parameters. And there's no star there because it's not a function pointer, it's actually the function itself. That's not something you can actually create in C. Everything has to be a pointer. You can't have a literal function object, but in GDB you can have a literal function object. So you can see now we're running 0.4.0. But there's a lot of other types in here. Often it's helpful that you can call them directly to find out what they are. You can ask for the type of something if you have an object. GDB has this unfortunate behavior that it tries to resolve JL type of as a macro, even though it actually exists as a symbol. And so you have to override its inherent system so that it'll use the right thing, and now we can ask questions like a type of, just as if we were in Julia C code, kind of as if we were in Julia code. And so we can then take a look and see, oh, this is a lambda static data, which, I mean, we already knew because li is declared as a lambda info. But if for some reason I doubted it or I just didn't know, that's a very straightforward way of finding out what it is. So those are a lot of my favorite commands. In this case, I haven't had to use any of the breakpoints or any commands like that. There's two classes of them that are very helpful. One is watch, and I'll try to show some of these in a future video, because just showing you that you can ask for help on them is probably not quite the most useful thing. But watch points look for reads or writes to a memory location. So if you have this particular variable, you're wondering when it gets set, watch is your ally. The one you're almost more likely to use is break. Break sets a breakpoint. You can see all of the function properties here, so we can ask it to break on a method. JL throw is often a very useful place to put a breakpoint. We could also place a breakpoint on a file and a line number. I can ask for info on those breakpoints. You can enable or disable all breakpoints. Now you'll see those have turned from enabled to disabled. I could enable some range of breakpoints or a specific breakpoint. It's a pretty flexible interface, but kind of hard to discover sometimes. I guess all the other things I haven't covered, all of the ways you can step or change threads. And might have to save that for more of a tutorial. I can jump back up to frame 0. Now, if I continue in any way in this, this is going to terminate the program, and that'll be the end of this debugging session. So I can actually do some tricks around that, and I could tell it to return. This will jump out of that stack frame. Let's do that again. Do that again. I just want to get out of the assertion functions. Keep going. Alright, I've gotten back to a set initializer, and now I can do all sorts of things. I can step by instruction. Oops, that didn't last for very long. Somewhat expectedly, I quickly ran back into the assertion. But I was trying to step by instructions so that it wouldn't do that too quickly. I could have also done the next instruction, which would have been the same, except if there was any function call, it would have skipped over it. Those are based on their friends step and next, which will go line by line in a program. Step going from line to line, and stepping through any function call. Sorry, stepping over any function call. Or actually, as it indicates there, you can add an argument, how many times. Oh no, I was right. Step goes to one next line which has source info. Next, on the other hand, goes to the next line of the current function. Some other useful ones are until, which executes to a further location. So you could do until a line, you could do a jump. Jump is a very interesting one because you can arbitrarily jump to a new location. It could be an old line number that you want to jump back to. You have to kind of remember this isn't resetting any of the program's state, so after a jump, your program state is probably invalid, but it can often actually be really useful if you got something like a seg fault, so your program's about to die anyways, you could jump back just far enough in history that you could re-execute a few of the commands leading up to the seg fault and look at the results if they were not otherwise available in the frame or the locals. That's about it, except for finish. I always remember this from the French fini or fin, or I guess they write that at the end of plays too. And this one has the helpful benefit that it continues executing whatever function you're in until it returns, and that tells you what the function returned. And so often when you're in some random function, you're interested in what its return value would have been, but you're not really interested in how it got there. Finish is the function for doing that. So that covers all of the debugging information that I believe we needed to solve the problem. And then, as I pointed out, we already solved this from the past information and put together an entire diff. It has some additional changes in here that are not related. So I'm going to do a git add -p, and the -p tells it that I want to be able to select which ones to go in. So I told that one not to put it in. Oops. So I skipped that one, and I could go take a look at it. And taking a look, this is the one I wanted to stage. So I say yes. Again, this one's good. Go ahead and stage that. Add that. Add those. Skip that. Skip that. Skip that. Good. So now I have in my stash exactly what I wanted. And these other things are unrelated. Depending on whether I think they might be interfering, I could stash -k. The -k tells it to keep everything that's in my current staged area, but stash everything else. But I'm going to go ahead and just commit this with a message. And now the message I want is I want to go ahead and say what I'm fixing and a little bit about why it was broken. Copy module before running LLVM cogen output passes. Alright, that'll give anyone who looks at this some later information. And then this will take a while to run the tests, so I'm not going to bore you with those. But I can go ahead and kick those off to show that they're working. Still need to pick my LLVM version. And I triggered a rebuild because of the commit. And that's it. I want to go ahead and actually add some of these fixes. But these are completely unrelated. And the final step then will be to push this. -n just tells it to simulate. Whether or not a push actually succeeded. And in this case, it tells me, nope, I won't be allowed to do that. So I'm going to have to go ahead and do a fetch. And go ahead and do all of the work needed to make this an actual all right, that should be good. So I would go ahead and then commit this to GitHub. And I haven't set up zero-factor authentication, so there's easy to do that. But once the push succeeds, it'll be done on master. If I wasn't interested in pushing this directly to master, I can create a branch right away, and I could actually just create one here. Fix 11878, and that, instead of pushing directly to master, will take my local master and push it to jn/fix11878. Then I can turn it into a pull request, give all the bots a chance to make sure I didn't break the non-mcjit versions of the code before I go ahead and merge that. So Git provides sometimes too many options. Thank you for listening. It was my first attempt, so give me feedback if you have any, or just forgive any flubs. Hopefully next time it'll be a little bit more polished.